Imagine you're suspended 1,000 feet in the air, held up by nothing but a spinning hunk of metal and a series of precise, microscopic tolerances. You think the helicopter is just a machine, but it's actually a controlled explosion of physics, designed to defy gravity through sheer mechanical willpower. Most people never think about the thousands of individual parts, each one critical, that must come together in perfect harmony just to keep you from falling. What happens next inside the most advanced hangars on Earth will change how you see every aircraft you ever look up at. We are taking you behind the heavy blast doors of an aerospace assembly line to witness the birth of a bird that refuses to fly like a bird. You'll see the raw ores ripped from the Earth, transformed into aerospace-grade titanium, and watch as robots dance with surgical precision to assemble frames that withstand forces that would snap a skyscraper in half. But here's what nobody tells you. The most dangerous part of building a helicopter isn't the assembly, it's the invisible microcracks that could hide in the metal, waiting for the perfect moment to fail. And this is where it gets truly extraordinary. Before a single rivet is set, we have to look at the ground beneath our feet. The spine of a modern helicopter is forged from titanium, an element so stubborn it requires an alchemist's touch to shape. Most of this titanium is sourced from the deep, brutal mines of Kazakhstan and Russia, where ore is pulled from the earth, crushed into dust, and refined to a staggering 99.9% purity. It travels over 5,000 miles to reach fabrication centers, costing upwards of $40,000 per ton. Think about this. The material you're standing on inside that cabin started as a jagged, dull rock in a desolate corner of the world. But it's not just the titanium that's traveling the globe, it's the carbon fiber, the high-grade aluminum, and the rare earth magnets that keep the avionics humming. These raw materials are packed into shipping containers that cross oceans, enduring salt air and humidity, only to arrive at facilities where climate control is more strictly monitored than a hospital operating room. If the moisture levels deviate by even 2%, the metal can oxidize, rendering it useless for flight. You might assume these parts are built where the helicopter is assembled, but that's rarely the case. The supply chain is a delicate web of global dependence, and if one string snaps, the entire production line goes silent. Once the materials clear inspection, the transformation begins in the forge, a place where heat isn't just a tool, it's a sculptor. Titanium billets are heated to a mind-bending 950 degrees Celsius, or nearly 1,750 degrees Fahrenheit, until they become malleable enough to be hammered by hydraulic presses exerting 50,000 tons of pressure. It's loud, it's violent, and it smells like ozone and scorched steel. The metal is forced into complex molds, compressing the grain structure to ensure maximum strength-to-weight ratio. What happens next surprised even experienced engineers. The metal is cooled at a rate of precisely 10 degrees per minute to lock in its structural integrity. With the frame components forged, the assembly moves to the CNC machines, where precision becomes an obsession. These machines operate at 15,000 revolutions per minute, cutting away excess metal to within 5 microns, that's thinner than a human hair, to create the perfect fit for the rotor assembly. Every second, the machine cycles through coolant to prevent thermal expansion, a process that continues for hours on end until a solid block of metal is whittled down into a delicate, aerodynamic masterpiece. You can actually hear the machine's high-pitched whine change frequency as it cuts through the final layer, a sound that signals the part is perfect, or that it's time for the scrap bin. Now, watch as the skeletons of these machines start to take shape. Human technicians, working alongside AI-guided robotic arms, painstakingly rivet the fuselage together. They use specialized torque wrenches that log every single turn, recording the exact pressure exerted on every bolt, a digital fingerprint that stays with that helicopter for its entire 30-year lifespan. If a bolt is over-tightened by even 1 foot-pound, the stress could lead to a catastrophic shear during flight. The level of human concentration here is absolute. One stray scratch on a structural member can cost thousands of dollars and hours of reinspection. Everything we've built so far is just a shell, a beautiful, heavy, grounded cage. Now comes the nervous system, the wiring, the flight computers, and the glass cockpit displays. Hundreds of miles of wiring are threaded through the fuselage, each connection tested for signal latency. Robots scan the completed electrical array with laser vision to ensure no wire is frayed or pinched. It's here that the machine shifts from a hunk of metal into a sentient-like vehicle. But have you ever wondered how they test for the invisible defects that could bring it all crashing down? We enter the quality control chamber, a silent, sterile room where X-rays and ultrasound sensors hunt for microscopic fissures in the titanium components. The rejection rate for a primary rotor hub is less than 0.1%, but that 0.1% could represent the difference between life and death. Every piece undergoes a stress test that simulates 10,000 hours of flight time in mere hours, subjecting the part to extreme vibration and heat cycles. Most people never think about this. Even after passing these tests, the engineers still perform a final, tactile inspection by hand, feeling for imperfections that the machines might have missed. That human touch is the final gatekeeper of safety. Once the assembly is cleared, the helicopter moves to the final integration phase where the engine, a turbine that generates more power than a dozen supercars, is mated to the drive shaft. This is a moment of pure mechanical tension. The gearbox alignment must be perfect to within 0.05 millimeters, or the vibrations will tear the helicopter apart the second it hits the sky. They use laser-guided alignment tools, but the sound of that first engine test? It's a primal roar that echoes through the entire facility, a warning that this machine is finally alive. With the world producing roughly 1,200 to 1,500 new civil helicopters every year, the global market for these machines is a staggering $30 billion industry. It's a sector that employs hundreds of thousands of people, from mining engineers in the remote reaches of the globe to software coders in Silicon Valley. 50 years ago, these machines were shaky, loud, and dangerous toys. Today, they're fly-by-wire miracles capable of flying in weather that would ground a commercial jet. Projections for the next decade suggest a surge in automated, electric vertical takeoff vehicles, moving us toward a future where the sky becomes as crowded as the highway. Did you know that the rotor blades of a heavy-lift helicopter can bend up to 3 feet during flight without snapping? Or that the tail rotor, which looks like a simple fan, is actually spinning at thousands of RPM to counter the massive torque of the main engine? And here is one that will blow your mind. If you were to unfold all the wiring inside a single modern helicopter, it would stretch for more than 5 miles. The complexity is almost impossible to comprehend, yet it exists for one simple goal: to defy the Earth and reclaim the sky. We've traveled from the deepest mines to the highest tech cleanrooms to see how a collection of raw ores and silicon becomes a vehicle that changes the world. We've seen the heat, the precision, and the human sacrifice required to build something that truly defies gravity. The next time you hold one of these in your hands, remember, it didn't just appear. It was born from the earth, shaped by fire, perfected by technology, and approved by the strictest standards in the world. That's not just a product. That's a masterpiece of human engineering. If you want to go deeper into the hidden world of manufacturing, tell us in the comments what product you'd like to explore next. Like this video, subscribe to the channel, and we'll see you inside the next factory.